Hello everybody. Today I'm going to show you how to create the geometry that you're currently seeing on the screen. Um, I'm calling it a Kinetic Pavilion. The reason why I'm doing so is because using those two sliders, I'm able to swing the geometry around a circle. You can imagine it kind of moving in circular motion. You can actually control both of them, which is pretty sweet. Other part of that tutorial is going to be having it connected to a Patrube server and being able to stream data from an online server, and then maybe using a Twitter account to send data to that online server and then streaming them back into Grasshopper to control that geometry. The ultimate goal would be to send Twitter messages to the Patrube server, and then sending those to your Arduino board to control some real mock-up models, maybe. Alright, I'll divide it into two parts. First part I'll show you how to get the geometry, and second part will be divided further into two more parts, and that will be how to set up the Patrube server, which is the now called Cosm server, and how to hook up your Twitter account to it. Alright, let's get started. You see how it works. So I'm gonna open a new document. First thing you want to do is to create two circles. So we'll need a center point. I already placed a point, but we can place any other point, whatever you want your circle to be. So we're gonna drop in a point component and set one point. And we need to draw two circles, one smaller and one bigger, to kind of create a basis for this catenary curve and then this catenary curve. So let's do circle by a center. So this point is going to be the center of the circle, and then we're going to need a radius. So if you double click and just type in a number, and I'm gonna make a circle with a 6 feet or 6-inch radius, whatever units are set up to. So here it is. Here's your circle. Next thing we want to do is actually draw another circle, which will be the outer or the inner circle for that matter. And I want to make that circle, if you go to math and do a division, I want to make that circle be a third of the size of that circle. So, and if you double click, punch in 3, that division component, plug it into a radius, and we use that same center. So here it is, our two circles. Next thing we want to do, create is two lines starting in a circle. So what we're gonna do is go to a curve tab and use the line component that has a starting point and the direction is a vector, and then the length of the line. So for the length of the line, we're gonna use the same parameter as the radius, and then the start will be the center, and then we don't want it to go vertically, so we're gonna use a vector x to have it go horizontally. And we want to create two of those lines. So vector x stays, this is direction 1, and the center line stays, as well as the radius. So we're basically duplicating same line twice. Next, we want to be able to rotate those lines, move them kind of around the perimeter. So I'm gonna drop in a rotate 3D component, and we're gonna need 2 of those. So you wanna rotate that line, and it will be easy to just punch in a number. I'm sorry, it will be easy to just punch in a number. However, it would not be able to, since all the numbers for the rotation angle, if we just type in 180, that will be in radians, which is not true. So we have to convert our regular numbers to degrees instead of radians. The way to do that is if we drop in evaluate component and maybe grab a panel, and there's a function called radian x, and what that does, it converts degrees into radians. So that will be our function. This will be our degree values, which is how much we want to move the line around the perimeter. We want to max it at 360 because this is as most as we can move it. So that will be our x, and that will be the angle that we want to rotate it for 8. Now the center point of rotation is the same center point as before, so we're just going to connect those here. So you can start seeing that I already created a line that moves around the perimeter from 0 to 360, so you can have a full range of motion. So I'm just gonna hide those two, so I don't see them, since the move component actually creates a copy of the existing geometry. So let's do the same thing for this one. Let's copy that, and instead of this, plug another number in, connect it here, and drag the center to the center. So now we have 2 sliders moving 2 of those lines independently. Okay, and that will be the basis. So the starting and the end points of those lines, so those 2 points over here and here, will be the start and end point for the calendar curve that we're gonna create in just about a minute. But before we do that, let's create the first calendar curve for the interior, since that will be a static curve. We're not gonna be moving it. The way I want to do this is I'm gonna actually drop in a point on curve, and I'm gonna need 2 of those. So you see I have 2 points on that curve, and I'm gonna set one to be at the start of the curve and another one right in the middle, so they're opposite to each other. And those are gonna be the 2 starting points for my catenary curve. So if you go to curve and spline, and then grab the catenary and connect those points to A and B. Now we'll need to tell it the direction of the gravity, whether it goes down or up. I actually want it to go up. So I'm going to go to Vector tab and grab a unit Z. And this is the G component, is the gravity. And the L is the length of the curve. I want the length of the curve to be, again, a third of the 16. 16 will be the longer one, and the shorter one is going to be a third of that. So I'm going to drop in my division component and plug it in. So here's our first catenary curve. Now I will need to create another catenary curve for the second one, for the second set of points. So first we need to grab those two endpoints. So if I go to endpoints under the curve and analysis and plug in the geometry, copy, paste, plug in the second one in, that gives me start and end point. Now I need to connect the endpoint to be one input and the endpoint from the other one to be the second input for it. This curve's length is going to be the full 16, but I'm going to be doing many divisions, and as well as I need the z to be defined. So there we are. So here are two of our curves, and they're connected to the lines that we can easily rotate around the perimeter. Now let me create the chords that we're connecting it. The way I've done that is that if you go to analysis, actually division, I'm sorry, and do divide curve, and let's do 55 subdivisions, and connect those to the number. The curve that's going to get subdivided is actually both of those catenary curves. So if you connect the first one and then hold shift to connect the second one, and you can see curve gets subdivided. What I want to do next is actually connect those with lines. So the way I'm going to do that is, so right now I have a list with 2 branches. Each branch has 55 points specified. So in order for me to create a line between point A and point B, I need to split those lists. So I need to go to sets, go to sets and explode the tree. And right now I'll have as my output just one branch with 55 points on it, and that will become the starting point, and that will be the end point. So next thing I need to do is draw a line based on 2 points. So that will be start, that will be end. And here we are. Okay. So this is it pretty much. In my definition, I've placed in a component that measures the angle between those 2 straight lines, but that's not really necessary at this moment. So here's our Grasshopper definition. We have our geometry working. Next step I'm going to show you is how to set up your protrude feed. So stay tuned, and that will be video number 2, the part 2 of that tutorial. I will explain how to set up your protrude, and then how do you connect your Twitter account, and then I'll show you how to put those together to drive the curve. So instead of those 2 sliders, we will have a Twitter account controlling those values. Alright, thank you for watching, and go to part 2 to see the rest of the tutorial.